Now we're going to integrate an exponential function. We're going to use u-substitution, even though we have a rule that we could use for this one, but we are going to use u-substitution just to illustrate how it works in this situation, again with definite integration, in other words with limits. So here we are, method 1, again we'll do it in the same order. So method 1, traditionally we've been ignoring the limits. Okay. Now remember, in an exam situation, usually you can use whichever method you want to. Occasionally they will ask you though to use the substitution method. Sorry, not the substitution method, but they will ask you to change limits. Okay. So it's the integral from 0 to 2 of e to the 2x minus 1 dx. And if you remember from the last section on indefinite integration, when you're differentiating exponentials, very often you simply let u be the exponent, the power of e. So if u is equal to 2x minus 1, du dx is 2. So du is equal to 2 dx. And if you divide across by 2, you get dx on its own. You get dx is equal to du over 2. So that's one of our substitutions, and this is the other one. Now, we're ignoring the limits. Okay, so the integral from e of e to the power of 2x minus 1 dx is going to be equal to the integral of e. 2x minus 1 is u, dx is du over 2. Pull out the 1/2. Integral of e to the u du is simply e to the u, so it's 1/2 e to the u. Now normally you would stick on plus c there, but since we're going to reintroduce limits, we won't do that. So it's going to be 1/2 e to the power of 2x minus 1. Okay. So without limits, that's what it would be. With limits, it's going to become integral from e to the 2x minus 1 dx from 0 to 2 is equal to 1/2 e to the 2x minus 1, again from 0 to 2. So we're going to put in 2 first. That's 1/2 of e to the 2 times 2 minus 1 minus 1/2 e to the power of 2 times 0 minus 1. And that's going to be 1/2 e to the power of 3 minus 1/2 e to the power of minus 1. Now you might want to write that in a couple of different ways. To write it as it is there is perfectly fine. You might also want to factor out the 1/2. And you could write it as e cubed minus e to the negative 1 is 1 over e. So it could be written like that as well. Okay, either of those two, perfectly fine. Okay, both correct. Okay, so that's it. We're done by ignoring the limits for a large part of the question. Okay, method 2 has been where we change the limits. Just scroll it up here. So method 2 is change limits. Okay, so if we go back to the question again, it was the integral from 0 to 2 of e to the power of 2x minus 1 dx. Let's just check that that was exactly what it was. 0 to e to the 2x minus 1 dx. Okay, and as you know, it starts off the same way. Let u be the power, so 2x minus 1. Du dx is equal to 2. So du is equal to 2 dx, and if you divide across by 2, you'll get dx on its own. Okay, and if I'm going too fast, just pause and play a little bit at a time. So now we're going to change the limits here. Okay. And we're going to use this u equals 2x minus 1 as our change of limits. And the top limit, getting out of control on me a little bit here, the top limit here was, in terms of x, was 2. So u top would be 2 times 2 minus 1. So 4 minus 1 is 3. The bottom limit in terms of x was 0. So the bottom limit in terms of u will be 2 times 0 minus 1, or negative 1. And now we can write out the original question, which was the integral from 0 to 2 of e to the 2x minus 1 dx is going to be equal to, okay, substitute the limits. The new bottom limit in terms of u will be negative 1, top limit will be 3. It'll be e to the u, and dx is du over 2. So pull out that 1/2, and it'll be the integral from negative 1 to 3 of e to the u du. Now the integral of an e to the u is simply e to the u. And because we changed our limits, we don't go back to x's again. We're going to use these u limits. Okay, and that's going to be 1/2 on e to the 3 minus 1/2 on e to the minus 1. Or, to put it in the form we had before, factor out the 1/2. You're left with e cubed minus e to the negative 1, which is 1 over e. And again, these should be exactly the same as what we had before. Now, we've spent a lot of time doing all of these questions 2 different ways. And you might be asking, why on earth are you doing 2 different ways to get the same answer? The reason for this is because this line here is very often what is asked in multiple choice. Okay? Write the equivalent statement or expression of the integral of 0 to 2 e to the 2x minus 1 dx in terms of u, in terms of a new dummy variable u. And rather than actually solve the question out to the end, out to here, very often in the exam you're being asked to write this part of it correctly. And that is why you need to be able to do things this way. It's not enough to be able to solve the entire problem. Often in the exam they're looking for this intermediate step. So hopefully that clarifies why it's needed. Okay, thanks for sticking it out this long.